RCOA, essentially we are a global e-learning community and academy created by professionals within offshore wind and renewable energy, created for professionals within the industry. So we offer role-based education where no other role-based education exists today in the market for offshore wind and other renewable energy technologies. And we pride ourselves on the quality of our courses and education programs, and we offer a certificate upon completion. We co-develop all of our courses with what we call Academy Partners, APs, and APs are experts in their field within offshore wind or other renewable energy technologies. And we have teamed up with many industry stakeholders and developers over the past years to create an industry standard framework as a response to the demand of targeted skill development. And we follow an ECTS academic framework. So without further ado, I'm going to hand the mic over to Chris to introduce our expert panelists today on UXOs. Chris, are you there?
Hello, everyone. At the table today with the following panel of experts. We've got Anders Mikulski, who's a highly experienced marine geophysicist working for COE, whose tasks involve conducting, processing and analysing UXO surveys prior to installation of renewable seabed infrastructure. We also have Oak van der Velde, who's an independent consultant UXO specialist. He's a chartered engineer with more than 25 years experience in this field and has actively been engaged with a large number of marine projects throughout Europe. And we have Hannah Finch-Saunders. Hannah's an independent marine biologist who's worked both onshore and offshore, studying environmental impact of subsea noise, and has been involved with pre-detonation mitigation and post-UXO disposal assessments of wildlife. And I'm Chris Weaver, Senior Inquisitor and one of the several senior course presenters at RCOA.
Right, so today we intend to give an insight into the importance of keeping our personnel and work zones safe by mitigating the risks from seabed munitions. Here you can see some of the dump sites that have been well documented across the world. I'm just gonna hang on. During today's roundtable, we've got just a short time to look at some of the important questions being asked, and on completion, our panel members will have time to take questions. So we will, if you do have a question that you haven't put in the chat, you can also raise your hand and we will unmute you. And also we will be publishing the questions on RCOA's student community, so you can also log in there to continue the discussion. So over to you, Chris.
Okay, so we've got 8 key questions which are quite often being brought up in discussions, and I posed these to the panel earlier to get them to think about them, and we'll go through these one by one. So first of all, why must we mitigate UXO risk in a subsea construction zone? And I'll first pose that one to Oak, our UXO specialist.
Yeah, good morning all. Thank you, Chris, for the introduction. Thank you for this question and the coming questions. To this question, yeah, why do we need to mitigate the UXO risk? Yeah, UXO risks are posing significant risk for life and safety, not only life on the vessels, but also the marine life, of course. An unplanned detonation could cause severe injuries and fatalities. And by adhering to the alarm principle, as most of us in the audience know, we can reduce the risks to an acceptable level. And how we do this, it's by detailed planning, clearance, safety protocols, and by adhering to that, we ensure the workers and the life is safety is prioritized. To the alarm principle, we dive deeper into it later on.
And how do we avoid unplanned detonations, Oak?
Avoiding unplanned detonations, we can mitigate on forehand by conducting a detailed UXO desktop study, risk mitigation, survey, and if necessary, conduct identification and clearance works.
And a question for Hannah. We've got with marine explosives on the seabed a pollution risk as well from leaking chemicals. How widespread can that be?
Well, I mean, obviously, I guess it's dependent on the size of the UXO in the first place, and then obviously you would consider all, the contents of such. As far as I'm aware, sort of my skills are very much more towards the marine mammal mitigation side of things and not the sort of leaking of chemicals. But, it's one of those things, the presence of any heavy metals that obviously can bioaccumulate up the food chain through fish up to marine mammals in the higher parts of the food chain is obviously a big risk.
And I assume there's going to be a risk as well if you've got crabs, lobsters feeding in an area where you've got loose chemicals on the seabed. That gets into the food chain, which we're the top of that food chain.
Absolutely, yeah.
Okay. And what about chemicals which are, let's say, warfare chemicals, the gases, etc., which have been not particularly used, but certainly dumped after World War II. Is that an issue? I have to unmute you, Ork.
Thank you for unmuting. I couldn't unmute myself. Okay. Yeah, the question about the chemicals. I've worked in the Baltics on the chemical dump sites, and we saw chemical bombs like mustard gas bombs completely corroded and opened with lumps of mustard gas laying on the seabed, fishes on top of it. Yeah, mustard gas is not dissolving in the water by itself. It dissolves when coming in contact with the air. So the pollution of especially mustard gas will stay for a long period subsea.
Right. Okay. Next question. How do we locate remnants of war? And moving on to Anders, this is your specialist subject, I think.
Yes, thank you, Chris. Thank you for the introduction. When starting a project and mitigating the UXO risk, you will need to conduct, as also mentioned earlier, a desktop study of the area, and the recommendation here is that start as early as possible. The desktop study is not localized on geotechnical positions or anything like that. It covers a broad area, so you only need to have a broad knowledge of where you want to conduct your investigations. You will normally contact a UXO specialist company specializing in these desktop studies, which will then look through all archives, historic data of the area to see what kind of naval warfare have been going on, aerial bombings, and so on. It is also recommended that, and the specialists will usually ask for this, is that you list all the possible activities that have seabed interaction. That's actually quite important to include, as the risk assessment will differ from the different activities like jack-up operations, drillings, closer to shore, it could be pile wall rammings and so on, all have different risk levels according to the to what kind of UXOs we might find in the area.
How long does it take to conduct a desk study typically?
To my knowledge, what the ones I've been involved in, usually 3, 4, 5 weeks, sometimes longer, sometimes even shorter. So it's not that time-consuming activity on a project. So start early on that one, and
Right.
the result of these desktop study will give you a normally a minimum threat item for each activity, which you will then keep on project for the rest of the project.
Okay. And the tools that are typically used to find explosive ordnance on the seabed, what are the main tools currently in use, and what can we expect in the future?
Yeah, we have 2 different kinds of searches for UXO. As you mentioned, the UXO might be on the seabed, depending on the local geology. If we have a hard seabed, bedrock or hard clays on the seabed, the UXO will not be buried. And as what we have at the moment, typically used are the side scan sonars. We have multi-beam echo sounders, anything that will create imaging of the seabed. These instruments will also cover a quite wide area on each path. You obviously have video from ROVs and so on, but these cover very narrow paths, so it will take a long time to cover a large area.
And for buried objects, I've worked off the coast of Germany, where siltation has meant that some things are well buried to maybe 0.8 of a meter. But what's the maximum depth that we can, at the moment, detect UXOs?
Yes. It obviously depends on the size of the UXO. Very large mines and bombs will be able to be detected at a longer range by the magnetometers, which are usually used. My experience to give a rough estimate of detection ranges will be that a typical magnetometer will detect a 250-pound bottom mine at 6-7 meters. The signal from the object will be able to be detected at a longer range, but it also has to be reliably detected as well. And that's also why we usually conduct trials to see what are the detection ranges in this particular area compared to the background noise and so on. And for buried, sorry.
No, I was going to say that's typically though for ferrous objects. What about when you're having to deal with aluminium objects, which a lot of the Luft mines were manufactured from?
Yeah, and these mines are notoriously difficult to detect. If you're using magnetometers, I believe usually they do contain a little bit of ferrous material in the interior instruments. But other than that, you will probably need to use some more acoustic instruments, some bottom images or multi-transducer seismics and so on to do a 3D acoustic image of the seabed to find these objects.
Okay. So if we've got buried munitions, do you get involved in the dredging, or is that the UXO Specialist company that starts to go down to try and expose them?
Well, I'm usually involved on the sideline, monitoring, being in contact with the client, and handling all the around organization, and then leaving the actual inspection and disposal to the UD experts and divers.
Good. So next question is, why isn't it possible to make a construction zone 100% safe from UXOs? And this is probably something that you, Anders, and Auk can sort of get together and tell us about why this can't be done.
So shall I start on this question? Like Anders mentioned, UXO desktop study is key in the answering this question, especially when we talk about, for example, the non-ferrous items. We like to determine in what area they are to narrow them down to have that particular solution only for that specific area. In that desktop study, we set a threshold, a potential threshold, which will be determined by the risk assessment for the project. For example, a construction phase has a threshold of 250 lips airdrop bomb. All objects smaller than that 250 lips will stay in situ, so we will decline them, so they will not be mentioned on the final master target list of objects to inspect.
So that's much smaller than if you were looking for UXOs on land, where you'd probably be looking for something the size of a small mortar bomb or a hand grenade. Is that correct?
Absolutely, that's correct. So a large amount of naval artillery will stay in situ. So that means that the construction site is safe for the construction, but not 100% safe from UXOs.
Yeah.
And above that, we also can miss a target, of course. It's a part computed, but also humans involved assessing the data, selecting the target, and a mistake can be made, of course.
Yeah. And there's talk with a lot of offshore processes now of using AI to identify things, particularly things like rocks. Is that now being used as well for UXOs?
So far, I haven't seen a widespread use of AI yet, but obviously the market for AI are rapidly evolving as we speak. So I cannot say it won't happen. Obviously, there are a lot of strength in AI that can cover large areas very quickly. I've seen boulder detection by semi-AI methods that are some are successful and some are not so successful, but they are still evolving as we speak.
Yeah. Okay. And I see a note here from Chris, I think it is. No, Carl Davenport at Kraken Robotics, saying that their acoustic system, which is the SBI, is capable of detecting ferrous and non-ferrous objects down to 5 meters below the seabed. This is certainly an increase in sensitivity compared with what we've been using maybe even just 3-4 years ago. So that combined with AI might give us a pretty powerful tool in future.
Where we see the SBI most often will reduce a large amount of false positive in the standard gradiometer surveys, which reduce, of course, significantly the targets to inspect.
Yeah, it's filtering everything out, isn't it? And just being left with the UXOs. If you can imagine it as a physical filter, like a net, you're going smaller and smaller and smaller until you're just left with the fine stuff falling through. But those nets will change in size as the techniques and the equipment gets better. Okay, well that's good. How do we reduce the risk from UXOs? First to Anders, because I've got avoidance. How can we avoid them? And is it expensive to do so?
Yeah, well, the to avoid the UXO are probably the most simple way of mitigating the risk. If you have a cable route, you can simply reroute the cables to through the exclusion zones of the UXO that have been found in the area. You will obviously have to account for if you have a cable, it can bend quite a lot, so you can zigzag in and out. If you have a pipeline, you have to be more straight, it's stiff. If you have a structure, it might not be able to move it to place it somewhere else. And if you decide to redesign, it can be quite expensive. Normally, UXO surveys are also could be quite expensive to perform. So you usually perform these surveys in narrow corridors or around borehole positions in small boxes and so on. So if you decide you want to avoid a target, you might have to conduct a brand new survey, expanding the area, and then it might actually be more viable to simply inspect and remove the or designate the UXO object.
Yeah. And if you're working in, let's say, sandwave areas which are mobile, and we've seen wrecks move around in sandwave areas and can sort of migrate, up to 100 meters or more. I've come across in high tidal areas. Is that the same with UXOs? Can they migrate in sandwave areas?
I believe the usual maybe all can also have some knowledge about that, but usually we say that the UXO will not migrate due to sandwave activity, but obviously the burial depth of the UXO will be greatly affected by moving sand waves. 1 year they can be exposed on the seabed, and a few years later they can be below a 6, 7, 8, 9 meter tall sand wave and be effectively out of range of detection of the UXO systems.
So that poses a different problem, doesn't it, when you've got a mobile seabed?
Yeah.
Yeah. Okay. That's good. So the next stage is, if we can't avoid them, there's a possibility of removing them over to oak. In Germany, for example, quite often the UXOs are transported ashore to be dealt with. It's something which I've not really aware of being so common in UK, unless it's something rare and somebody wants to investigate the weapon a bit further. Is that your finding, Jan?
So yeah, lift and shift operations of UXO in Germany are more or less forced by the government, and that's the only reason for that is to avoid noise peak detonations subsea. But to relocate a UXO, you need to be 100% sure what type of UXO it is and what kind of fuse it's on the UXO. without 100% ID of knowing the origin of the target, the type of fuse, the state of the fuse, you cannot move safely UXO back to deck or do a lift and shift to the beach, for example. But yeah, in Germany is more common than in the UK. In the UK, you will see lift and shifts to avoid detonation near subsea infrastructure, for example. But
I was going to say, Hannah, you might have a bit more of an insight as to UK going to go more for air detonations, which cause far less environmental damage than underwater explosions.
It's not something that I'm aware of, but I know that the UK government at the moment are piloting a lot of studies that are looking at how we can reduce the noise created in a lot of sort of offshore industries, wind farm installation, and I'm this is almost certainly this as well, because they all have the to a different amount for each, but same resultant risks. But yeah.
So there's no sort of strict policy that's been formulated yet.
Not for not that I know specifically to do with lifting them out to detonate them outside of the water. Not specifically that. Obviously, we have our methods in which we can try and reduce the noise emitted if in the event that detonation is required. We have various noise abatement systems, mainly the bubble curtain actually, which Germany use a lot for various offshore industries, and it's something that we've adopted here in the UK for high order UXO detonations.
Okay, well, yeah, that brings us nicely onto the destruction side, the high order and the low order, the detonation or deflagration, and there's been a high-profile campaign in UK from Joanna Lumley to adopt low-order deflagration, because the noise emitted from that is far, far smaller than a full explosion. And certainly that's been used up in Scotland, and it appeared to be quite successful. And I assume that from a Marine Mammal Observer's point of view, is that easier for you to monitor?
Oh, absolutely. I mean, the precautionary principle that we follow in the offshore industry as a whole, but specifically in relation to the marine environment, is really important. And if you are towards the sort of last options of having to sort of detonate the bomb, the UXO, sorry, deflagration should always be considered, because the resultant effect on the damage it can cause to marine mammals is really significant compared to detonation. So yeah, I think absolutely consider the low order techniques, and if they absolutely don't work and the high order are required, then obviously we've, as I mentioned, we've got noise abatement systems, but the importance for sort of thorough planning is really, really important. A really thorough environmental impact assessment, using noise modelling, to try and estimate the sort of impact ranges of various sized UXOs, environmental considerations, so depth of water, and then obviously, depending on the potential effect, looking at what noise abatement systems you can use, having a strong marine mammal mitigation plan in place, which, you've got a good team of marine mammal observers, passive acoustic monitoring, and the use of acoustic deterrent devices. They're all options that we can employ to just try and bring the overall impact down to sort of the most negligible level as possible.
Yeah. What's your experience of deflagration versus detonation? Is deflagration the silver bullet, or are there still some issues?
there is no simple answer to that. High order detonations fully eliminate the risk, but generate noise, of course. We want to reduce that noise, but low order detonations by deflagration, for example, it's not as easy as answered as you say. Yes, it has less noise peak subsea, but you see most often that you need to do a secondary attack because you have leftover residues or you have booster charge still in place. You need to reconfigure your secondary or third attack to determine if all explosives are gone, yes or no.
Yeah.
So by introducing low order techniques, you might end up with more vessel days per disposal. So in some cases, up to 3 days, you are in the field with not only the disposal vessel, but also with the noise mitigation vessels, with the bubble curtain vessels. So on one hand, you reduce and you safeguard the marine mammals, but on the other hand, you have pollutions, topside, of course. So it's not a simple answer to the question, is low order better than high order? Yes, in some cases it is. But there are new techniques coming, and I feel that the offshore industry is not ready or not willing to introduce those new innovations, and that's a little bit of a pity because there is more than low order and high order detonations.
An interesting question just come through. What's the likelihood of an unintentional detonation when trying to neutralize UXO using low order methods? I know that that big tall boy did go off and it wasn't supposed to in Polish waters.
So you have that we call it like a violent low order. That's a low order ends up in a high order. There is no 100% guarantee that a low order will be successful. So I always try to plan for a violent low order. So mitigate the low order as it's going to be a high order.
So you've got to use a bubble curtain there as a backup, just in case.
Depending on the size and the TNT calculation on the target, of course. If you have a small artillery shell or you have a British ground mine, that makes a huge difference in noise peak.
Okay. We'll move on next to noise, and these are really questions which Hannah's very experienced with. Hannah, can you quickly tell us what the difference is between temporary threshold shift and permanent threshold shift is? Oh, just I need to unmute you. Can we unmute Hannah?
I think just a minute. Oh no, I'm sorry. There we go, Hannah.
Okay. Carry on, Hannah.
Yeah, sure. So temporary threshold shift is basically, when you're conducting any operations in the marine environment, they have the potential to cause, oh, my screen's changed, injury or damage to marine mammals, but they can recover from that damage or injury. Whereas permanent threshold shift is, as it suggests, permanent damage caused to marine mammals, and according to our UK regulations, causing permanent threshold shift to marine mammals is considered an offence to do so.
So that's the hearing, really. It's the noise side of it. But of course, with an underwater explosion, you've also got the shock wave. So how does that affect the animals? Obviously it depends how close they are, but it's never fun being next to a very noisy disco when you can almost feel the noise going through you from a speaker. Underwater, that must be quite something. And I assume that shockwave is going to cause permanent injury and death with many species.
Yeah, absolutely. So obviously, depending on the degree of the shock wave, it can cause mortality. It can cause a permanent threshold shift, which we also refer to as the primary blast injury. So it can damage their sort of air-filled spaces in their body, so their lungs, their guts, which obviously can directly sort of harm them. But it can also significantly affect their hearing, which obviously they rely on heavily for communication, finding mates, finding food, navigation, and their hearing is so sensitive that as soon as that is harmed and they're unable to recover from it, you've almost signed that's as good as, it's as good as mortality.
Death warrant.
Yeah.
Yeah, and of course, all these explosions, we'd like to think, we're doing it at the best time, but you can't always do that because you've got different species migrating at different times, haven't you? And
Yeah.
that, I assume, is all part and parcel of the desktop study to find out that information.
Yeah, absolutely. So the EIA process will look at, exactly where the UXO is located. Is it close to any protected areas, special areas of conservation? Is it time of year dependent on when it's wanted to sort of get rid of it? Is it a crucially important sort of feeding or mating area? So yeah, it's all those questions that come into sort of the EIA process.
Okay, good. Oak, what's the optimal time for disposal? Can you do it round the clock or is it daylight only?
At the moment, most of the disposal operations are daylight operations. That the one and only reason is to allow the mammal observers to see the mammals. You increase it. You can increase it to 24-hour ops when you put more advanced monitoring systems on the vessel, of course.
Okay, and I assume with if you're going for low order, you can do your detonation during daylight, but you can do your clearing up during the night.
Yeah, the preparation works are done during the night, and the clearing up of fragmentations is also done after post detonation during the night.
Okay. And we've already mentioned kind of seasonal restrictions. Obviously, you're specifically looking at mammals, but it's worth mentioning, there's fishery activities, there's spawning, nesting seasons for birds, and if you take away some of the primary food sources for seabirds, it can have a devastating effect. So do you see that after an explosion there are a lot of fish sort of floating belly up on the surface?
Yeah, sure. So yeah, as I mentioned, my focus is sort of the marine mammal aspect, but absolutely. And as part of our role on board as MMOs, PAM operators, ADD operators and such, part of the marine mammal mitigation protocol does also include a sort of post-detonation search of the area in which we record anything that has been harmed, and we do take fish counts of any fish. If we can identify the fish to sort of species level, then we'll make notes of that. But yeah, so you do get fish floating up after a detonation.
Okay. In terms of port traffic, we seem, when we're actually destroying a weapon on the seabed, we know we're working with fairly standard distances away from it, depending on the size of the weapon. But do the ports work with those same sort of distances, or are they sort of far more risk averse and say you can't do this while we've got a tanker maybe 2-3 miles away coming into port?
Yeah, it's all in conjunction with the port authorities, of course, but also where is the location of the detonation? What's the TNT content of the UXO? Standard, we try to avoid detonations within the 4 miles of a shore, because the shock wave will end up on land.
So it's 4 miles from the shore. If you're within that, you're starting to affect housing and people feel it under their feet. Is that correct?
Yeah, that's correct. But that's a rule of thumb, of course.
Yeah.
That it's in the
Depends
disposal
on the
plan.
size.
We make a planning and calculations for every subsea asset, for example, cables, pipelines, wind turbine, monopiles, and every asset, every traffic lane, also air traffic will be taken into account.
There's a question on here which says, is there a standoff distance considered to be safe between a design route and a UXO? In other words, if UXO's so far away from a cable design route, what is that distance that it's considered to be safe and you can almost ignore it? Maybe Anders can put us right on that. Can we unmute? There we are.
Yes. Well, normally if you are staying outside the exclusion zones determined by the desktop study and the UXO survey, you would normally just ignore that object. Obviously, you have to take into account any future activities in the area. If you're planning to do additional cables along the original one and so on, you might benefit from thinking a little bit ahead and removing objects beforehand. But normally, if you stay outside the exclusion zones, you would normally be fine.
Okay, so it's all designed and you've got this cable corridor, and that's what we clear. Anything outside that cable corridor is not going to have an effect on the cable, providing it's put down the center line. Is that correct? Is that my interpretation? Great. Okay.
Chris, to add something to that, that is a correct statement. Although with the current speed of renewable energy offshore in the building, we see now wind park next to wind park next to wind park, and we find a large amount of UXOs in the neighbor's wind park, so close to the existing infrastructure. So for that time it was safe, but in an unknown area with unknown objects. But now we find those objects and we need to lift and shift them, because we cannot detonate next to a wind turbine generator.
That's a very, very good point. You know, they are so close together that just because you think you've dealt with everything in Wind Park A, it doesn't mean that something found on the fringe of Wind Park B isn't going to affect Wind Park A. So, yeah, worth consideration, isn't it? It's certainly not simple. Right. So, why is a clearance or ALARP certificate needed? Over to you, Oak.
Yeah, it's required to reduce the risk of course in the planned zones. So wherever there is a construction planned and there is identified in the desktop study potential risk on UXOs, we need to do something. And by accurate planning, you can reduce unnecessary cost for future.
Yeah. And Anders, obviously, when we're doing our work, it's great to see a paper chart, but a paper chart doesn't help the guys steering the ship or driving the ROV around to stay within the limits. So how important is it to get this information and to promulgate it accurately and regularly to everybody involved as a GIS overlay?
Yeah, it's obviously very important. The captain on a vessel will not be able to look at a paper sheet and just see where he is according to that. Obviously, you need to have some GIS workspaces. You have to incorporate these exclusion zones, work zones directly into the navigation systems of the vessel. Even more so if you're doing jack-up operations, you need to know where the exclusion zones are compared to the jack-up, the spot legs at all times, so you are not placing anything inside a exclusion zone. So very important, and the communication between the client and the vessel and the UXO specialist are critical in these operations.
That brings me nicely onto the last question, which is, should a client just appoint a contractor to deal with the UXO issues and let them get on with it, or is more engagement from the client needed? And Hannah, have you come across any issues where the client thinks, well, we'll just let them get on with it from MMO side of things?
Yeah, I mean, I've been working offshore for over 10 years now, and definitely, you know, earlier on in my career, I noticed that we were very much, you know, directly associated with the client's position on board. And then obviously more recently, we've been more sort of employed through the subcontractor. And I definitely think that there's a responsibility on the client to take full accountability and responsibility of their environmental mitigation measures, as opposed to sort of passing it on for the subcontractor. And I think, you know, just from a freelance point of view, I've noticed that you know, we're not as involved in the politics as much when we're sort of directly with the client. And I think also from the licensing body's point of view, you know, it's for the client, it's for the client to take full accountability and responsibility of their mitigation measures, and in them sort of being directly responsible for us, that enables that. You know, the book basically stops with the client.
Yeah, yeah. Anders, what's been your experience?
Yeah, very similar experiences as Hannah, and we have seen both sides where the client have been very involved and are taking responsibility, that they are actually hiring in subcontractors, and they are requiring requiring monitoring of these subcontractors, that everything is done according to safety regulations and so on. I've also seen clients where the focus has not been that clear, saying just get on with it. It's your responsibility, and I think we need to get a little bit away from that, and especially keeping budgets and other outside parts out of the discussion.
Yeah, there's always the budgetary pressure, isn't there?
Yeah.
Oak, what's been your experience?
Yeah, I think clients need to be heavily involved in UXO risk management process, but contractors are bringing the technical experience. They bring in the experience, the certificates to conduct UXO survey ID and disposal. But the client needs to oversee the project's objectives and align with the regulations in the area of operations.
So it seems fairly straightforward that you all agree, you know, we need to engage the clients more in what's going on with UXOs. So we come to the final takeaway points. We're running just a little behind schedule. Hannah, what would you like people to take away from this UXO discussion?
I think just the importance of sort of going through the due process of determining, does the UXO require sort of detonation or deflagration, and if so, making sure that you've completed a thorough environmental impact assessment that includes noise modelling, to look at the impact ranges and in order that you create a really strong marine mammal mitigation protocol that brings the potential impact down to sort of the lowest possible risk to marine mammals.
Yeah, good. Anders, what's your takeaway?
Yeah, my takeaways is that the more front loading you can do on these investigations, the better. Do a proper planning and make sure that always keep in mind that the safety of the crew on site is the key focus at all times in these construction zones.
Right. Auk, what would you like to take us away with?
I only can say ensure safety without compromise. So that's my takeaway, and it's not as low as reasonable, practicable always, but achievable. What's achievable in the project.
Great. Good. Well, we're rapidly running out of time. We've only touched on a few aspects, but we have covered quite a few of the questions which have been popping up in the boxes. So I'll hand over now to Michelle, and then we might have time for maybe just one or two of the questions we had before we started. Michelle.
Chris, and thank you to all our panelists. Without further ado, let's just dive into some of these questions that were emailed to us, because we took a lot of them on the chat, and the ones on the chat we will also post in our student community along with answers in the next few days. One question that was emailed in was, how real is this risk in places like Australia, if so?
Yeah, I'll answer that one. Basically, you think of Australia as being well away from most of the issues. Northern Australia, you had a lot of munitions drifting around from island engagements, particularly mines, etc. We also have to remember that Australia has practice ranges, and when I say practice ranges, it's not dumb bullets, it's quite often live rounds. So there will be munitions on the seabed there. There will also be wrecks, and there might be commercial wrecks carrying munitions. There might be military wrecks. They could be aircraft. So it all depends which area it is. But the important thing is to do a study, a desktop study, to find out first. Next one, Michelle.
Yeah, I'm going to start at the top. Topic: noise mitigation and release of chemicals when doing UXO clearance. And there's a question here. What are the common practices to attenuate the propagation of noise when detonating UXOs, and how the release of chemicals in the water when doing deflagration is contained? I know you touched on this a bit earlier, but...
Yeah, well, I think Hannah's already mentioned bubble curtains, and those seem to be widely used. Is there anything else, Hannah?
It's not something I've had direct experience with, but I know that some of the large companies such as Van Oord are bringing out technologies such as resonators, which basically you position them around the noise source, and they attenuate the noise frequencies which are considered most harmful to marine mammals.
Right, because of course you've got harbour dolphins, which are in quite a different league in terms of noise. Like we've got babies that can hear much higher frequencies than adult humans, but harbour porpoises have a much wider frequency than any human, and of most whales. So it depends on, I suppose, the species and how you can sort of keep that noise down.
Yeah, absolutely. So harbour porpoise are one of the ones that we sort of strongly consider because of their frequency range up to sort of very high frequencies. And that's it really. It's the potential impact on any marine mammal is associated to what frequency range it listens at.
Yeah.
Chris, to add the second part of the question about the chemicals due to low order detonation. Yeah, there are chemical residues in the water by low order detonation, but there is almost no study how much that is, and
No.
yeah, there is also no mitigation for that at this moment.
No, I mean we see these deflagrations on the seabed where they've tried out a new system, and you've got the weapon cracked open and maybe a few blocks of explosives there, but the surface area of the explosive, how old it is, all that will come into play as to how quickly it disperses. And the ideal thing would be to scoop it up before it gets a chance to disperse, isn't it?
So new techniques are developed at the moment in, for example, the US to drill a hole in a UXO and bladder it out. So by doing that, you keep the residue out of the water. You cannot employ it on every UXO, but it is an option for the larger airdrop bombs, for example.
Sounds quite complex.
Yes, but it's doable.
Good. Have we got time for one more, or are we wrapping up?
We could do one quick more and then wrap it up. I don't know, Chris, if you want to choose it. There are a number in the chat. There's one here, PUXO target discrimination topic. Do we talk
Yes,
about
target discrimination. That might be a good one for Anders to have a look at. Do you want to read it out for me?
Actually, not a question. Hang on. There's a topic. Wait, hang on. No, there's a question.
Okay.
How are PUXOs confirmed as UXOs or non-UXOs? What is the standard minimum detectable size?
Yeah, that's the one.
Yes, maybe I can answer a little bit about that. I'll start with what is the standard minimum detectable size. Obviously, it depends on the equipment used. Obviously, the magnetometers can detect magnetic signatures from quite small objects. It could be hand grenades and such, especially if the magnetometer is quite low to the seabed. But in these cases, the signatures are usually lost in the background noise from it can be boulders and other rocks and boulders that are magnetic and so on. So you get it'll be very difficult to actually identify what's a boulder or what's a small grenade and so on.
We often forget as well. We've got naturally magnetic rocks in some areas on the seabed, and that completely throws the whole scheme for looking for weapons.
Yes, exactly. Especially in Northern Europe, where we have a lot of glacial tills and so on. There's a lot of boulders in the sediments. Exactly. Yeah. And on how are potential UXOs confirmed as UXOs, or maybe I can answer that. But obviously, it's you have to normally you would inspect the object.
It's down to a visual, is it, Oak?
Yeah, it's down to a visual that can be done by numerous ways, by ROV, by diver, by remote system, multi-tool systems, USVs, AUVs. Yeah, there are numerous of ways to inspect a target, of course.
Okay, great. Well, I think we've run out of time for questions. I'll just finish off with my thanks to Oak, Hannah and Anders. It's been a very interesting discussion today, and I hope everybody who attended has enjoyed it. And I'll leave Michelle to wrap up. Thank you.
I'd like to express my same thank you to all our panelists and to you, Chris, and very much appreciate it. And we will share this presentation, and please spread the word and share it onwards with your colleagues and ensure safety in your workplace. And take care. Bye for now. Thanks, everybody.
Everyone.
Thank you.
Thank you.